So some of you asked me to explain 5.9 gas pressure and volume, and I'm going to start by explaining just the build-up of this chapter, of this unit, that I'm sure some of you will be helped by that. So it starts with basically a statement. I've highlighted that in pink. The volume of a fixed mass of gas depends on its pressure and on its temperature. So we're looking at, and I should have written that here already, a fixed mass is M, and the pressure and the temperature. So basically what they're saying is that you have a number of molecules in a certain space is the volume, and the force they apply on the walls, that will affect the volume, and the temperature will affect the volume. So that's how much energy they have. After that, an example follows where is explained how these three things affect each other. So I'm not going to walk you through that. I will. Some other examples will follow. Then another. It's not more an example. It's more an investigation, an experiment to show how pressure and volume are linked to the temperature. And then at the bottom of that page, there is an important conclusion that the pressure increases as the volume decreases, and the opposite, pressure decreases as the volume increases. And I've written that in symbols. Personally, that always helps me, because it's sort of, those words sort of become their numbers. So pressure goes up, volume goes down, pressure goes down, volume goes up. I'm sure that will help a number of you. Then on the next page, this is explained a bit further. You see in pink again, I've highlighted the formula, and this is a very important formula in science. Actually, around this formula and a bit more extended version of the formula, there's a whole separate subject built around it. It's called thermodynamics. And thermodynamics, I mean, I studied that 6 months when I was at university, because it just goes so far. Anyway, this is a very simple version with just pressure and volume. And as you can see, what it says is that pressure times volume is constant. Now, in the part above, in the highlighted yellow part, it is explained how they get there. So it says for a fixed mass, which is M, the number of gas molecules is constant. So basically what they say is you have an amount of gas, and the number of molecules stays always the same. It's logical. If we have one molecule that has a certain mass, if we've got two molecules that has a certain mass, doesn't change. Doesn't matter what the temperature or the volume or the pressure is. So that is fixed. Then it says if the temperature is constant, the average speed of the molecules is constant. So the temperature, as I said, basically is the indication for the energy. So the temperature is constant, that's T. The average speed of the molecules is constant. Then comes if the volume of that fixed mass of gas at a constant temperature is reduced, so goes down. You see I've put V with an arrow down. Then the gas pressure increases. So there we go, P goes up. And they explain that because the space of the molecules move, the space the molecules move in, so the container, let's say this is the container or that is the container, the space they move in is smaller, so they do not travel as far between successive impacts on the surface. So they move, they bang, they move, they bang, they move, they bang, and that goes faster and faster. That's why pressure increases, because the space has become smaller. Think if I lock up your class with 29 or 30 people, first in room 114, which is very big. Now you can move, you don't bump into each other. If I then move you into the room next door, which is really very small, then obviously you will bump into each other. Then the last bullet point says that molecules hit the surfaces more often, so the average forces of the impact increases. So here they're talking about bumping molecules first into each other and then the molecules bumping into the wall. So I hope this this shows you the relationship between how the volume and the pressure when the temperature is the same and the amount of molecules stay the same. So that's how they come to so-called Boyle's law. Pressure times volume is constant. I'll record a separate video where I explain the worked example here on the right. Back to the learning objectives or learning outcomes. For what you need to know is for a fixed mass of gas at a constant temperature, you need to recognize how the pressure or the volume changes and they affect the volume or the pressure, so other way around, and explain in molecular terms why the pressure of a gas changed when its volume is changed. And also the extension, recall and use the equation PV is constant. And I just want to show you how that movement or how the molecules relate to what we've done already. So here we did gas pressure. We started this period doing solid, liquids and gases. Then we learned more about solid, liquids and gases, and here especially the movement of molecules in a box, in a closed space. And then here gas pressure and temperature was introduced, and then evaporation, which is not got to do so much with gas law, and then the gas, basically what we call the gas law, gas pressure and volume. Hopefully this helped you, and I'll be back with the worked example.